saya buat kerja, saya akan sleep je. So banyak saya buka, jadinya saya punya RAM tu slow, rendah.
Miss ni je tutup Google Chrome, tutup yang banyak-banyak tab tu.
Tak nak, itulah pasal saya takkan tutup. Sebab bila saya tutup nanti saya lupa apa yang saya buat sebelum tu. Okay.
Nanti saya recommend, tak apa. Ni lagi.
Okay. So we're going to look into overview, cache mapping scheme, replacement policy, cache performance. Basically our 6.3 ni is quite long. So saya harap we tak bosan lah ya. It's quite long, and after this we're going to cover 6.4 because this one is only about 10 pages, just a bit of theory, it is not too much. So we proceed with cache memory. Last time we did see, okay, I nak kena balik pula, lupa pula nak tunjuk dia punya pyramid. Last time we did see on this pyramid. If you still remember this pyramid in our early 6.1 subtopic, we have this pyramid, and on top of this pyramid, it is your CPU. The closest you to this top, which is the CPU, so the nearest, you're going to see that you have the more faster access time and then the highest in cost. You can see the closest each cache if you compare with the main memory. Now we're going to compare only Alhamdulillah, only cache and also main memory. So only between these two. And the cache memory is closest to the CPU. Cakap boleh tak? Jangan komen.
Tak ada komen lah.
Sebab saya dengar.
Tu admit tu.
Tu ada orang angkat tangan tadi tu.
Oh. Okay, what happened? Angkat tangan pun cakap lah.
Entahlah Miss.
Okay. So I continue kalau if you want to ask me anything, if you want to say it, please just unmute yourself. Okay, so the closest you to the CPU, your time is much smaller, much faster. Because what later on, I think last time also I did say maybe we can assume that like 1 second, so that's why when you want to go back, it's going to take much longer. It is like logic things. So today we're going to see, if you see over here, you have cache several level. You can have several level. Maybe you can have only one level, maybe you can have 2 level, maybe you can have 3 level. It's depend on what type of your computers that you are using, and if your computer have several caches, then it's going to be maybe it's going to be good. So today we're going to learn it. Kenapa ni? Ayo. 6. Sebaik I tak decline. Okay, so the main memory is the central storage unit in a computer system. This is the one that you know, and you already see that in your memory you have a RAM and then a ROM. And throughout of this, you can see there is several also other in term of RAM and ROM. I hope that you still remember, it's just yesterday. And the principal technology used for the main memory is based on semiconductor integrated with your RAM. But as yesterday also, you can see that we had learned a portion or a small part in a main memory also can be integrated or conducted with your ROM. So under RAM, yesterday we learned either it is static or dynamic, which is SRAM or DRAM. That's on the main memory. So this is just a bit small recap for you to recap a bit about yesterday class. The PS over here, what is important? The most main memory main memory is general purpose computer made up of RAM. 6 point. Patutlah saya rasa saya dah wait saya salah baca slide ni. Patutlah tiba-tiba main memory lagi. Okay, sorry. So that's about main memory, and today we're going to look into cache memory, which is when you want to design. When you design your cache memory, it is a combine of first is the memory access time. You see on the pyramid, it's going to be expensive, the highest, and if the highest in speed also. Second is large memory size, less expensive. So it's lower speed of memory. You ingat balik the pyramid. So the fastest, and then it's going to be smaller, and also the cost is increased. So that's why the cache memory are using these combinations. The cache content of copy of portions of the main memory. So apa kaitan dia? What is related to memory is its content copy, not something new, but something already inside the main memory, but it's just copy just to put it into the cache. That's why kalau you punya Google apa semua kan, you boleh delete kan cache you punya sistem punya memory under cache. You boleh delete. Tapi nanti you punya macam password ke semua hilang kan. Macam tu je lah sebab but it's already in your memory. On top of that, you can copy and save it into your cache. Unlike main memory, which is accessed by address, normally kita belajar semua before this we are using address. 4001, 4002. So this is the address. And this is all related to your main memory, your register and etc. Cache is typically as Sekejap saya banyak sendawa ni. So typically accessed by content. So you know if you want to access to cache, you will look into the content itself, not the address. Hence it's often called, so that's why in terms of cache, you can call it with a different name, which is content addressable memory. Okay, you can see over here, it's look like your pyramid system, which is your cache is much closer rather than your memory with your CPU. So first you're going to meet your cache first. So that's why you can see whenever you want to have like, I bagi you simple situation, our normal daily life, let's say, this is your friend, this is you, and this is me, let's say. When you want to have a connections, your friend send you a message, request something untuk you balas, cakap, kelas hari ni ada tak? Tapi bila dia communicate with you, it's only 1 second. Saya tak guna millisecond ke apa. We just do the example. So 1 second for each. And then you akan reply. Sama you punya, maksudnya you takkan saja nak reply lambat ke. You dapat je, you akan terus reply. You punya jenis macam tu contoh. So it is another 1 second. So altogether, your friend will get 2 second. So 2 second you will get. And then you can see over here, if let's say your friend ask me, that's why lah lambat kalau nak minta saya balas tu kan. Your friend ask me, first it's going to be lalu you dulu. Dia tanya you dulu, tapi maybe kata I don't know. You dah balas kan contoh lah. Tapi bila dia tahu you tak ada jawapan tu, then it's going to be you pula tanya I. So it is 1 second, another 1 second. So then I akan balas. I akan balas dekat you dulu 1 second, and then you akan inform your friend 1 second. So altogether your friend dapat balasan tu dalam masa 4 second. Your friend get the answer in 4 seconds. So which one is fastest? Of course the nearest, right? So this is just a example only. So that's why over here, I think if I'm not giving you example also you will understand. Genius kan budak UTM ni. So it is much faster rather than if you compare, if you want to deal something, if you want to fetch something inside the main memory. So if you want to fetch something in the cache, it's much faster. And what is the communications between CPU and cache is on the words transfer. You're going to transfer on the words. While from the cache to the main memory, we're going to use a block. So this is if you are having only single cache. So you punya masa only 4 second. Kalau you are wanted to go to up to main memory. But if let's say you have several, let's say you have 3 level cache organizations. So you're going to see like maybe this one is 1 second, 1 second, 1 second, 1 second. Just one round, not when received back is already 4 seconds, and altogether it's going to be 8 seconds. So that's why you can see faster, fast, less fast,
It's 9 hours.
slow. So this is the slowest if you want to fetch something. So much further, you're going to see that it's going to be much slower. Then you can compare to the pyramid again, or that's why main memory is slower. Okay, cache mapping scheme. After this, you're going to learn on mapping scheme under cache. Kalau you tengok, if you still remember yesterday on our main memory, we have techniques like you want to susun, you want to organize your memory, how you learn on two, which is HOI and LOI. Now in the cache, it have their own scheme, their own format, and on the main memory also you have a format for HOI, for LOA, how you're going to have the address and etc. In cache also we're going to learn similarly, we're going to learn the mapping scheme, what is the format on the cache, and we're going to look into it. So the content that address in the addressable cache memory is a subset of the bits of the main memory address, which is called a field. But in terms of feature, you will not see the fields, I think, but it's okay. The field into which memory address is divided provide many to one mapping, which is between large main memory and also the smaller cache memory. So again, the PS over here, many blocks. If you have many blocks, yesterday you can see you have many blocks in your main memory, right? It's going to map, daripada you punya banyak ni, you going to map only to one single block of cache. This one is cache, this one is main memory. So many block of main memory are mapped. Going to map it to a single block of cache. Aduh. A tag fields in the cache block distinguish one cache memory block after another. So you're going to look into the picture. This is about sentences. Now you can see a picture. This part on the right side, I'm not going to explain anymore. I think it is already familiar with you. This one we already look into the block under our memory, main memory. So let's say we have block 0, block 1, 2, 3 until the block m-1. And of course, you're going to see your memory address over here. The end of the address will be -1. This one we already discussed yesterday. And the length over here, it is the word length. This is on what we learned yesterday under our main memory. Now we want to see the cache, how it's supposed to look like. It's totally different. You can see you have a block. Now this is all new term for you. Over here, it is not yet memory address, but it called as a line number or a slot. You have slot 1, line 1, line 2, line 3, and etc. until -1. And what is the similars is on the block length. Here is a block length, but over here at your main memory, it is a word length. Jangan tertukar ya. It's not going to be 100% similar, but in terms of like a length and so on. So it's similar, but this is block length and this is a word length. And your blocks is divided into like this. And for the cache also it's similar, only that this is the block length, how many blocks that you have, and this one is a tag. Later on you will see what is the tag and also the line numbers. So yesterday we look only two technique, LOI, HOI, but in the cache you have 4 total mapping scheme. Cache may has 2 or 3 fields depending on the mapping scheme. Sekejap Okay, sorry. So these fields depend on the particular mapping scheme being used to determine where the data is placed when it is originally copied into cache. So you basically have the data, whatever data is from your main memory. So this is from your main memory, you just copy it into your cache. And you can see over here, there is 4 scheme altogether. First is direct mapping. Second is block direct mapping. Third is fully associative mapping. And lastly, the set associative mapping. Now we're going to look into the first scheme, the first technique, which is a direct mapping. You're going to apply it direct. And on top of that, you need to know from all these 4 mapping, this is the simplest. This is the simplest, but the techniques, I think it's not too simple. This is a simple technique. A cache structure is in which memory locations is mapped to the exactly one location in cache. So from the memory location, you're going to map it into one location in cache. So how about the format? Last time you already learned on the memory format. Now you look into the cache format for the direct mapping. So your main memory address will look like tag, and then you have a line slot. This one is if you are dealing with your main memory. But when you have the cache memory, you're going to have this line slot will be in front. And as previously, you're going to see when you want to fetch something in the cache, you will look into the content. So that's why you will see on the content. If you go to the previous slide and the main memory, you look, this one is not a content, this is what? Data, address, something like that. So you need to know what is inside. When you want to fetch something for the main memory, it's totally different from the cache. So here is the cache address, and this is the cache words address, I think, in the main memory. Please look back. So the example, how you're going to calculate, how you're going to define how many bit for tag, how many bit for line. So let's say you are given a main memory contain 8 words. Again, I want to remind you, please make sure you see whatever behind the numbers. For me, if I look, I'm going to read several times. Ni saya lah, saya akan check several times. Same goes to like whenever I did the exam, I akan baca berulang kali until I faham. Kadang-kadang I macam baca tapi apa aku baca macam tu. So I'm going to read, and satu yang saya tengok budak-budak sekarang ni, what I see is after you finish, let's say your exam is from 2 until 4 PM. And then around 3 PM tu, ramai sangat dah keluar exam. Ramai sangat dah leave and then dah submit. But for me, walaupun let's say I already finish at 3 PM, I will wait until 4 PM. Kita orang dulu dekat Dewan kan, kita orang akan nampak berapa orang yang keluar. Tak ramai tau yang keluar. Tak ramai yang tinggalkan Dewan tu. Mostly budak-budak lelaki lah, diorang pandai kan. So diorang yang akan keluar. Perempuan ni akan tunggu lagi. So kita orang akan pada saya akan tunggu, saya akan check berulang kali, walaupun benda yang sama kita check. Selalu orang double check sekali je kan. Saya akan check sampailah masa tu habis. Kita orang takkan bangun. Mostly perempuan macam tu lah dulu yang physically. Tapi bila saya tengok saya mengajar hari tu dekat Utah, student akan, kalau habis awal tu keluar terus, diorang akan keluar daripada Dewan. And then I had one student, seorang je student Chinese, sebab Utah dulu student ni semua Chinese. Terus seorang student Chinese ni dia akan tinggal dan dia akan senyum je pandang semua orang keluar sampai habis masa. Saya macam student ni a bit weird, because budak sekarang tak macam tu. Kalau dulu tu kita orang dah biasa dah dekat, kita orang akan keluar betul-betul waktu habis. So saya tengok sekarang pun when you dekat punya macam you punya e-learning kan, e-learning we can see when you click the submit button. Tak ramai yang submit ataupun biar je dia akan submit on betul-betul tepat masa ataupun betul-betul sebelum. Mostly akan submit awal. Saya nampak ramai macam tu. Mungkin saya tak tahulah budak sekarang terlalu pandai kan. Macam saya takut nak hantar awal. Okay, that is selingan je. Then over here you can see 8 words. While the cache has only 4 words. Dia it give you the main memory size and also the size for the cache. Using that using direct address mapping, identify the fields of the main memory address. You need to identify fields for the main memory address. Okay, let's say you have a main memory, and yesterday we look, whenever we have something's a numbers, we're going to make it to the power of something over here to the power of 3, and this one is to the power of 2. So we want to see the bit. How many bits for your main memory? How many bits for your cache? Now you're going to see you will require 3 bits for your main memory and 2 bits for your cache. And this one is normally this one, if for the cache words, it is also known as a cache address or a line or slot. Alhamdulillah. So this one, we want to identify the field of main memory address. You look back over here, you have your main memory address. You have tag and line slot. Okay, your format will be like this. So of course you will see your main memory total up all 3 bits. You punya format, you're going to have the tag line or the line or the slot, and also the tag. Now you know this part, which is 2 bit. Baki dia, the rest is going to be 1 bit. Tak payah nak tolak-tolak. This one is you going to go congak aja. You direct calculate it, you're going to get it. Isn't it? So this is the field of your main memory address. How you going to justify it? So the text size will be 1 bit. Now after that, if you want to deal, because you're going to find the address and you're going to look into the cache memory also. This part I dah lukis ya, I already draw this, and now we're going to look into the cache memory. This is 1 bit. This is 2 bit. And over here in cache memory, how you going to define it? So you have only 2 bits for your cache memory or slot. Selebihnya, how you going to do? I made it more beautiful. Over here, you know already. Tadi you dah calculate kan? 1 bit. So this one will be 1 bit for the tag. Just copy it from the main memory. This is 1 bit. And the rest is the content of your cache memory. All together, going to see how it's going to look like. Okay, this one is your address. So address over here, you're going to see if you have 3 bits to the power of 3, your address, how many possibility you're going to have? 8. You calculate 1, 2, 3, 4, 5, 6, 7, 8. Ini you dah belajar dekat you punya digital logic. You dah belajar 00, 00, 01, 10. Kalau ada 3 bits, you going 000, 001, 010, 010, 011, and etc. until up to 8 bits. And the highest is going to be 7. 8 minus 1. So that's why you get 111. So you can see over here in front of this, you have tag 0 and tag 1. But You can see your tag 1 is 1 bit. So 1 bit's only over here. And this one is 2 bits. And if 2 bit is not going to be long like this, it's going to have only to the power of 2, 4. 4 possibility, what you're going to have? 0, 0, 0, 1, 1, 0, 1, 1. This is the tag and this one is the rest is your address. Okay, nanti you nampak dia punya lukisan. So dekat sini, this is your main memory. And inside is your content. Ni. Saya tengah duduk ni, so saya kena selalu mengubah position. Okay. Okay. So under your cache memory, you're going to see you ada 4 only. See, it's going to be 0, 0, 0, 1, 1, 0, 1, 1. So this is your line slot. Sorry. So and over here is going to be your tag. And inside is your content because it is vice versa, terbalik macam tadi. So this one is your address, this one is your content for your main memory, and you have the tag and also line slot. Where you going to apply your line slot, where you going to apply your tag. You need to know how you're going to draw it. And how about the cache also? This is your line slot in front. Not like your main memory, your line memory, not like your main memory, your line slot is behind the tag. So the tag is in front and your line slot is behind. So now you can see your tags, you don't know what is the value inside and also your content. But the tag, you can see if you have tag plus M, you're going to have the total of your cache memory address. So that is like how you're going to draw and you're going to apply it. So later on, we're going to go deeper inside. Now, if let's say you were given with your memory content of 32, again, please make sure you see this. Is it a word? Is it a byte, a bit, and so on? Whether there is a unit over here or not. If you look comparison between example of last yesterday exercise and example, you're going to see it is K, right? Kilo. Wait, apa benda ni? Okay, so over here you can see, you lukis dulu. You have 32 and what is 32? 32 equal to the power of 5. So 5 bit. You have all together 5 bits for your main memory. And you still remember this one is the tag and this one is the line or slot. And using using direct address mapping, again you're going to see you are given the techniques that you need to use. Identify the field of the main memory address. You need to identify the field inside berapa and so on. Okay, so the total saya tertinggal pula ni. Cache only have 8 or so to the power of 3. To the power of 3 is 8. Okay, so you have cache is to the power of 3. This one cache sama je kan? Sama kan dengan soalan ni, is already give. And this one is your line or slot. Mana tadi? Okay. This one is for line or slot. Now you know your line or slot is 3 bits. And also, of course, you will know that your tag will be 2 bits. It is not too hard, right? It's easy. So your tag size is 2 bits. That is how you're going to find the field for your main memory address, which is your tag size. Okay, now there is another example. For this question, I want you to do on the mega by yourself, which is you need to use your scientific calculator. Because over here, as I mentioned, when you have a numbers, please make sure you look behind. Please make sure you know what is the unit that represent. So over here, you have 64 kilo words. So 64 is to the power of 6. Kejap Aduh. Okay. 64 kilo words. So 64 kilo words, you need to know that I ni lupa ingatan. So I have 1, 2, 4, 8, 16, 32, 64. 0, 1, 2, 3, 4, 5, 6. Okay. This is going to be 6. 64 equal to the power of 6. So this will be 6 bit. But you have kilo over here. If you look, kilo is to the power of 10 yesterday. I forgot already. Please make sure you look back. And over here you can see. Okay, this one is memory. If you still remember kilo, we have on the example yesterday class, it is to the power of 10. So that's why you will get catch or your line or slot will be 2, 6 times 2, 10. Because it is kilo, right? So atas ni akan tambah ni matematik kan. Tak kalau saya nak ajar pula you all lagi pandai, lagi hebat lagi ni. So that's why you will get to the power of 16. And the 16 will be the bit for your line or slot. Now you dah tahu about your cache memory. Dia beri lagi, your main memory is 64 mega. Mega today just we made it. Yesterday we see the example on kilo. Alhamdulillah. So 64 again is to the power of 6, and mega I don't know, you can check. Now I just want to see the example over here. Okay, assume that it is 220. So I hope that it's correct. And nanti you tengok yang ni. Okay, so over here you can see you have to the power of 6 times with to the power of 20. All together for your main memory, you have to the power of 26. So this is the bit for your all overall of your address. Supposedly you're going to have 26 and your tag and for your tag over here, you don't know tag size, and your line is 16. So selebar dia you're going to have 10. So your tag size equal to 10 bits. Determine word size of your main memory. Okay, so this is your memory dah dapat. Cache and the main memory address format. Okay, so now you look, you have another one which is your cache for your word size. Two of the example is only on the main memory address, which is your text size for your memory. Same goes to another example. Mana dia? Okay, this one. So in this example, you need to find the cache and also the main memory address format, also your main memory size. You already sampai over here. And it's give you another hint. Tadi kita sampai sini je kan kita baca. You just read until here. And you can see you have 8 bits of word. Dia punya panjang tu adalah 8 bits. 8 bits for your main memory. That's why you can see you kena darab lagi dengan 8. We apply it similar macam what we learned yesterday. So that's why your main memory on the words, you're going to see you have 8 bits. This is your memory. And how about your cache words? So cache word, you need to know the equation for you to calculate is tag plus number of word in cache multiple with your size. So you have the tag of berapa tadi tag 10. And then you plus with your words. Words, what is the words value? Number of word in cache. So dalam cache dia tak beritahu memory cache. So you're going to have assume it as a 1. This one is a main memory. Memory 8. So cache is 1 only. You multiple with the words of a size of your main memory. So you will be getting the 18 bits. That is what cache word. But now you need to see the format. So you can see you have altogether 28 bits. This one I already showed in the previous slide, 16 and 10. And how about your cache memory? Under your cache, you ada mula-mula line or slot, and then you have tag and content. So dari sini your line or slot tadi, you can see you have 16 altogether, and this will be your cache memory. Okay, this one is your tag. Tag will be 10. So altogether you can see you have 26. Sebab you going to be same. But in terms of content over here, you need to see that you have add bits is already given, add bits for the contents, and you will get all together plus this one is 18. Tag and content, it will be 18. So the cache words, how are you going to calculate? Cache words going to get 18 bits, which is tag plus your word in cache. So that's why you will get like this. This one we already learned how to get, only that how to calculate the content. That is the equation for that. And all together you can see cache tag is tag plus size of content. You're going to get 10 plus 8 plus equal to 18 bits. And this is how you get the format for your cache memory and your memory. Main memory is quite easy because you need to calculate only 2, which is tag and also line slot. Normally line slot it will be given. So next is under hit and miss. Apa hit, apa miss? I think yesterday also we already go through about hit. Then there is a several if you still remember the table. So please look back. And you can see because we already look into the hit, now you can see about the miss. Cache miss. A request for the data from the cache that cannot be filled because the data is not present in the cache. So a request from data that request for you from the cache that cannot be filled because inside it is not present, tak ada data dalam ni. Let's see. So this is under your main memory and this is your cache memory. Again, you can see the format is still similar, tag, line, slot. And then for your cache memory, line or slot and then tag, content. So this is the format that I want you to remember. So let's say over here you have from my memory, you want to find something and then you're going to hit your content inside your cache memory. But if there is nothing which is not present in the cache, so it's going to be missed. So example number 10 over here. Example number 10, which is catch, hit and miss. The question is here. A main memory content of 16. Again, we want to see the numbers. We want to convert it into to the power of something which is 2 base and we will get to the power of 4. Betul kan? And after that, we need to look what is the unit behind. So over here, it is words only. There is no any other units. While the catch only have 4 and look back, okay, it is only words, so to the power of 2. So your main memory is all total up with 4. And your catch or line is 2 bit. Of course, your tag will be 2 bits. This is just congak je you akan dapat. So this is all showing here. Sama je macam example sebelum ni. It is similar with previous example. So you will get the text size. Apa dia punya soalan? Using direct address mapping, it already give you the techniques or the schemes that you need to use. Identify the field of the main memory address. You need to identify, you dah draw. So, you dapat this line. So, this is just example if you want to deal with your cache memory because the question is asking you the main memory address. You need to fill the tag, how many bits, the line slot, how many bits, how it look like. And if for the cache memory, you're going to have the line slot and then you have tag and content. Of course, you don't know what is inside because there is nothing details that given to you to put the tags and content. But in terms of the format is going to be look like this. As I mentioned, if you have 2 bits, you're going to have 4 possibilities. That's why you will get 0, 0, 0, 1, 1, 0 and 1, 1. For main memory also you can learn doing that, but for you can see 4 times over here, which means 4 bits. You can see the address, you're going to have the 16 possibilities. Okay, this is best. See, this is 16 Let me calculate. Kalau I tengok 16 until 15, 15 is 15. Kejap actually, I just nak share dengan you. Sempurna audit. Ini semua kawan saya ni asyik suruh saya tukar school. Because I'm from School of Electrical, basic I Electronic. Bila I masuk dalam School of Computing ni, saya kena mengajar programming. I really don't like. But I like IoT, I like artificial intelligence. I like project basically. So project dia I lebih berminat dekat sini, but in term of the skill of student, I do believe that School of, jangan marah School of Electrical student dia lagi bagus in term of project, because they are dealing with hardware, but most of the computer student always give a reason, we just know on programming, on hardware we lack of skill and etc. But in School of Computing, School of Electrical, you need to play around with hardware, you need and you must, sebab you kena tengok benda tu. But when you want to let the electronic thing works, you need to know the programming also, so they have multiple skills. So that's why kenapalah student-student saya now, for my PhD student, they give a reason, I don't know about hardware, I just know about programming. So don't put that things in your mind. Kalau you rasa you want to be a flexible student, you nak berjaya dekat akan datang kerja, so jangan hanya tumpu dekat you punya pelajaran. So diorang suruh saya tukar pindah ke School of Electrical, tapi I like project under School of Computing. Kalau dekat I pergi School of Electrical, I don't have IoT. Although yes I can, but the student focus on like electronic, electrical, and I like one more things is artificial intelligence, and I start to learn on that. And the new thing is blockchains, right? So now currently the trend is still under IT. So I think I'm going to fix over here first. If I want to apply IR later on, somehow I need to teach there. School of Electrical. Although my background is electronic, I cannot apply IR if I at School of Computing. So macam tu macam rugi sikit kan. So I need to teach there. Then I can get. So over here you can see the examples, as I mentioned, for the main memory is going to be 16. 16, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All together 16 possibilities. And you can see this one you know already. 0, 0, 0. No need for me to show you. Especially also under hexa. You know that after 9 it's going to be A. It is not going to be 10, but it's going to be A, B, C, D until F. And the content inside is the hexa. This one is, I think that is just an example. What is the content in the hexa over here? Because there is no any clue what is content inside in the question. Based on the previous example, consider the following main memory with content. Oh, then it mentions consider. You need to reconsider what is inside. And this one is similar like beside here. You have the 4 possibility for your cache memory. Another example is example 11. You can see you have the cache hit miss operations. The main memory you were given with 32, and again please make sure you see the behind. 32 is to the power of 5. Kalau saya silap bagi tahu ya, saya ni dah tua. While the cache is 8 to the power of 3. So you will get 8 bits for main memory, 3 bits for your cache. Using direct address mapping, identify the fields of the main memory address. You're going to have the main memory address only. If you have 32, how many possibility is 5 bits? You're going to have 32 possibilities. Dia ada lukis tak panjang? Yes, it is have. So you kena lukis on that, which is main memory, but macam mana how it's look like. But this one is the format. So daripada sini terlalu senang. I don't think that I'm going to repeat one by one because semua example tadi kita play around with this. We want to find the text size. This one we already know the line size. Line size is 3 bits and of course the text size will be 2 bits. So we get the format for the main memory. Same goes to the cache. We can have it also 3 bit for the line or slot and tag and content. We have over here 2 bits. And this one, it asks you to follow the main memory. You're going to see all together. You're going to have 32 possibilities, and the n is 31 because what is -1 because you are starting from 0. So all together is 32. And this one is similar in the previous, and you can see the difference is on your cache. Now you can see your cache having 8 possibility because it is to the power of 3, right? So 8 possibility you're going to see, and content over here is not given you anything, so you just put the x-axis for now. Based on the example, show the content of the cache as if respond to the series of requests. So it give you the hint on the decimal address. So you need generate address. So you have address and then content. So content you is already given. This one is already given, and your address you need to see. This one is address that given to and in the decimal 22, 26, 22, 26, and etc. This is the already given. And because of this, you can also change this into the binary. On the binary side, this is content, this is not address, so you cannot convert 22 to hexa in the content. This is content that already given. And how about your memory size? Is it from previous example? No, right? Okay, this is another new example. So you were given this kind of format. Complete the table or it is meant from previous. So you can see over here, if let's say you have 1, 2, 3, 4, 5, 6, 7, 8. So they give you only 8 possibilities. They bagi you example of 8, and this one is on the address. You can see you have 000, 000. Also, it's depend on the question, I guess so, because we didn't have any clue where it start. Adik, jangan kacau adik, biar dia dulu. Okay. Okay, how you going to put it into this table? So whether it is how you going to read it as a read or write operation cache? This is the format table that later on you will learn, whether it is hit, miss, update, cache, read or write. You need to compare between the cache memory and main memory tables. This one, as I mentioned, is already give to you. So this is from the question. So you need to complete another new tables. So based on the example, shows the content of the cache. So inside the content, you need to show it, okay? And as response to the serial request. So decimal number is already given. and you just need to change it into the binary later on. So it's similar like this. You change to the binary and you need to have a format address. This is from previous example. You have similar value. Okay. So you're going to see what is this green. What is the hit? What is the miss? So you need to see, as I mentioned, whether when you are asking or request for your cash, if you look back for the previous, what is the meaning of miss when you try to find 111 inside your cache, is it available or not? You're going to see there is no casting in term of your formats. You don't think you don't have. So that's why you're going to miss, isn't it? Going to miss. And of course, after every single of like request, you're going to update. You're going to update and you will write an update to your cache. Second, 110. Kelas 110. So you're going to see 110. Abang ada 110. Okay, that's 2. Then you're going to see the tag. Content hexa dia, alamak dekat sebelah. 110. It is hexadecimal. Over here it's already give, okay? So you tengok content is in hexadecimal. So the text is here. So that's why you will put it here. But it is not miss because you have the value inside the content. And why it's miss? I need to check back the miss over here. So after you have the value, you can see. I think it is reading upside maybe for the first time, and then second. Then this one I will update and inform to you. And you can see over here, when you find the value, you're going to put it inside your cache memory. And the value of your content is already given is 91. And you will also update your cache, and then you're going to write. Second, you're going to see why it's going to go down. I think it's reading is 0001, 1011, and etc. So I delete it. Then you can see over here it's jumped to 010, but it's okay. You can see over here 101. If 101, it is not here, then you're going to miss. That's why there is no value inside, similar to 111. So over here you're going to miss, and 100 also is not here. That's why it x. 010. 010, you have 000 tags. Over here you're supposed to have 00, and then your content, you need to check what is the content in a hexa. 010. You 010. You have 11 over here, then you will put over there 001. It is not, and then you have x, and another one is 000. It is 10 for your tag. So this one is I just show you first in this slide of the cache memory, and then later on we will see this, and you can see I want it to fill in. Okay, you can see it fill in the value. It fill in the value what I said. Then the rest there is no value, isn't it? So you can see how it's updated in the cache memory depends on your in cache memory depend on your main memory. Why it's feel like this? You need to check. And about this one 010, you can see you have 010 value is 11. And then another one, you have another 010, it is 11. But if you go through, then you will check and double check until you can see another one, 010. Now it is 10. It's going to update because it's going to read one line per line. So 010, another one is 10. So that's why after that, you're going to see you update cache, you update cache, you update cache, and you write, and that's why you're going to update it with this new value. Okay, then you see the previous slide. So all the content is already give in this previous table. You can see it's already based on the table. Mana dia punya ayat tadi? Okay, shows the content and the cache. So you already given the contents. So you just pick it whenever you have, let's say 110, you're going to see the contents. What is the content? And for 010, first you have F4. And then you have another one. You meet F4 again. You have another one. You're going to have F4 again. But throughout, you're going to see you have another 010, which is different from the rest in your main memory address. Then you need to update with the new value. So you can see over here. First is F4, and then you will get 02, and you will update. So this table, I want to double check, and I will re-inform you. I don't want to give you a wrong understanding. Then later on, if I want to change it, then it's going to be hard. So you focus on this first. From here, you will find the value inside your cache memory, and you're going to look and fetch it from your main memory. So you need to look one by one, single line and single line. What happened to the hit and miss, I will update you later on. So that is on the example. You have another one which is exercise 1, and there is also solution, but I don't want to give you first. We will discuss this later on in our next class. So in this part, I will give you a video, and also I will give you example answer also. So please make sure you try to do it. If you cannot do this table, you can focus in this part. It is not too hard when you were given the value. I guess this one is what pages? Oh, I afraid that I forgot. 55. Oh, we have another half. So I guess the rest also I will update you with the video, but focus on first the example for the hit and miss. So please try to do the exercise, and we will continue later on in our next class. And on top of that, I'm going to give you with the video for the example, and also the continue rest of the modules, because I don't want we going to be late. As I mentioned, if let's say we have near to the test 2, we're going to have a discussion also, especially in class for your test 2. Again, I mentioned I have no update related to your project work and also your test 2. If I have an update, we're going to discuss in the WhatsApp group, and also for the test 2, we're going to have the revision class. So is there any question? Ya. Adik bawa dia turun, kenapa dia? Ya Allah.
Adik dah boleh tak?